This is the third mini-lecture for section 4.3 of the textbook. In the last two mini-lectures we were talking about the greatest common divisor. Now let's talk about the least common multiple. Notice right now we're talking about multiples, not divisors. Remember, those words have different meaning. If a and b are natural numbers, then their least common multiple is the smallest natural number that is a multiple of both. So what we have to do is list the multiples of the two numbers and just find the one that is the smallest number that is common to both numbers. So, for instance, let's look at 15 and 21. Okay, what I'm going to do is skip count by each of the two numbers. With 15, the multiples are 15, 30, 45, 60. Let's pause there for a moment. You know, these keep going forever, as we've seen. It's an infinite set. So let's pause for a moment, switch to 21 and see if we've got anything yet. So we have 21, 42, 63, 84, and no, nothing yet. So let's go back to 15. Let's see, next there's 75, 90, 105, 120. Let's switch back to 21. Okay, well the next one's 105, so we're done there. I'll do one more just for dramatic effect. So it'll be 126, and so on and so forth. So those two lists keep going, but we just care to take it to the first common element, which is 105 here. So the LCM of 15 and 21 is 105. Okay, here's one place where it's really important to have the words multiple and divisor straight. I very frequently see students try to answer this question of what is the least common multiple by saying something like 1 or 3. So if a student does that, that shows that they are seeing the word multiple, but they're getting it mixed up with the word divisor. Okay, the least common divisor would be 1. But since it's always 1 for any numbers, it's kind of silly to ask what it is. Okay, that's not something we're really interested in. What we're interested in is the least common multiple. And you get the multiples by multiplying the number, or by skip counting by it. So this is a method that always works, but again, since we're just listing multiples, sometimes it could take a while. So we'll begin talking about a better way to do it. Now, notice that the least common multiple of 15 and 21 is not 15 times 21, which is 315. Okay, 315 is certainly a common multiple. Okay, it's a multiple of both, but it's not the least one. It's not the smallest. The problem with just multiplying these two numbers is that they share a 3. But the least common multiple only requires one factor of 3. 15 is 5 times 3, 21 is 3 times 7. If I multiply 15 times 21, I get 5 times 3 times 3 times 7. But I really only need one of those 3's. So if I do 5 times 3 times 7, okay, that's 105. 5 times 3, that's the 15. The 3 times 7 is the 21. So I can see the two numbers inside of there, but I don't have that extra 3, so that multiple is as small as it could possibly be. So in general, while a times b is always a common multiple of a and b, it is not typically the smallest. Sometimes it is. But what we can say is that the least common multiple is less than or equal to a times b. So that's to kind of alleviate our concern that we might have had from the last slide, that if we're just listing multiples, we know those are infinite sets. how do I know I'm ever actually going to get to something that they share? And this tells us that yes, you'll definitely get to something. Worst case scenario, it's A times B. That's as large as you may have to go. If that could be a very large number, but it's something that's finite. Okay, but usually it's not the smallest, and that's something that comes up all the time when you're finding least common denominators in fractions. So they're different concepts. Least common multiple and least common denominator are different concepts, but they're very closely related. And what we're talking about is necessary to understanding that concept of fractions. Okay, so like I said a moment ago, we can kind of shorten the work if we use prime factorizations. So let's think about 18 and 45. 18 is 2 times 3 times 3. 45 is 3 times 3 times 5. In order for a number to be divisible by 18, it has to have at least a 2 and a pair of 3's. So if a number is a multiple of 18, and I look at its prime factors, it's going to have at least a 2 and a pair of 3's. Similarly, if a number is a multiple of 45, when I look at its prime factors, I'm going to see at least a pair of 3's and a 5, because those are the factors that make up 45. So the smallest number that meets both requirements would be 2 times 3 times 3 times 5. So if I look at that product, 2 times 3 times 3 times 5. Okay, 2 times 3 times 3. Oops, that's the 18. And 3 times 3 times 5. That's the 45. So you can see the two numbers overlapping in there. But if I were to remove any of these factors, I would be losing at least one of them. So this is definitely the smallest number that contains both of those numbers inside it. Okay, and this product is 90, so that's the least common multiple. Okay, now we saw before that A times B is typically larger than the least common multiple, and that's because anything they share in common gets counted twice. So one way to find the greatest common divisor, the least common multiple, would be to just multiply the two numbers, but then get rid of the stuff that got counted twice. Yeah, the stuff that got counted twice is precisely the greatest common divisor. So basically, we could just multiply the two numbers and then divide by the greatest common divisor. So let's try that with 1492 and 1776. So I'll divide 1492 into 1776. Goes in there once. We get 284 left over. Okay, now let's divide 284 into 1492. See, I'm doing the Euclidean algorithm because using that I can get to the GCD quickly and then use that to find the LCM. So I divide 284 into 1492. Goes in there 5 times, I think. Okay, so we get 1420, subtract, there's 72 left over. Now we'll divide 72 into 284. That goes in there 3 times. Okay, I get 68 left over. Okay, then I have 68 into 72. Goes in there once. 4 left over. And then I divide 4 into 68. And that goes in there 17 times. We'll just do that all at once. And now there's 0 left over. So that means that 4 is the greatest common divisor. So the greatest common divisor of 1492 and 1776 is 4. Therefore, the least common multiple of 1492 and 1776 is 1492 times 1776 divided by 4. So let's just see what that is. Okay, so I'm getting 662,448. So here is a problem where you would probably definitely not want to try to list all the divisors and multiples using rainbow diagrams and skip counting, because that would take a really long time. You would probably also maybe not want to use prime factorizations, because again, that might be kind of time consuming. This method allows us to get at both of these numbers without going through all those steps. Okay, so the homework is exercises 1 through 10. It just focuses on the 3 methods: intersection of sets, prime factorizations, Euclidean algorithm. If you're asked to use the Euclidean algorithm to find the least common multiple, do what I just did right here.